Okay, we're going to do a moment of inertia integral, and I haven't even defined what moment of inertia is yet, but we'll get to that because everybody in class here knows that moment of inertia is what you get when you add up all your MR squareds. And of course, that's because both of you are in physics, and we just more or less proved that yesterday in class. Okay, so we know what moment of inertia is, so I'm just skipping to a moment of inertia integral because it's going to benefit you here and there, and it's a fairly intuitive concept. Okay, disk of radius r, mass m, uniform density. Okay, so we want to describe the region by inequalities. Now, I'll get on you just a little bit because I assigned you 3 sections 12 days ago, due 5 days ago, where you had to do this, okay? So you're going to have to make that up and progress into triple integrals, okay, within a week. So in rectangular coordinates, well, how do we describe the region? Y'all aren't doing real well with that one, okay? That's because you haven't thought about it since we did it 12 days ago and you've lost everything we did. Don't let that happen. It's inefficient. You get a lesser grade for more time input, okay? I understand you're balancing things and you're in a really tough semester. So I'm not ready to write you off as evil and incompetent, okay? But you really have to learn these lessons and balance things better than that. If you'd have spent even an hour thinking about these things, you'd be able to answer these questions based on what we did 2 weeks ago, okay? So, you always need to spend that time as soon after class as you can to reinforce what you've seen. Don't put it off. Even if it's only 15 minutes, don't put it off. Because it starts to lock it in, your subconscious starts working on it. End of lecture about that. Now, in polar coordinates, it's real easy. R goes from 0 to big R, and you get all the R's between here and there, and theta goes from 0 to 2 pi, and that totally describes your region in a way that will make more specific when we actually set up the integral. Okay? And rectangular coordinates, R goes, well, X can go from negative R to R. Now, when I first asked the question, how do you describe this? You said, well, Y goes from negative R to R2. Well, if X goes from negative R to R and Y goes from negative R to R, you get a square, not a circle. So you have to ask yourself what happens for specific X. Okay? So this will be a specific sample X star. Okay? If you can find X to just this one value, X star, then Y goes from here to here. So, for typical X star, Y goes from here to here. And of course I've written this, so I can't even figure out where the arrows are supposed to go, right? Make sense? Okay. So tell me what the coordinates limiting Y are. What is the lower here? What's the upper here?